We'll be talking about creating an ARIMA model for time series analysis and doing some kind of basic forecasting works using the ARIMA models in R. So the basic is you should really have a decent understanding of what an ARIMA model is. Auto-regressive, integrated, conditionally heteroscedastic model. Oh, sorry, moving average. Auto-regressive, integrated, moving average model. So we are doing the time series modeling using the ARIMA model, and once a appropriate ARIMA model is created, we will be getting into the forecasting for the future for that particular data. So it's one of the important class of linear time series models, right? Whenever we have a time series data and if I have to model it, this is one major category of models. This is also called as a Box-Jenkins kind of model because it is typically named after the person who has really proposed this kind of a model. And we need to understand some of the basic things here. Whenever we have the current value depending on the past values, right? This kind of models we use whenever we have an impression that the current values are dependent on the past values of that same time series data or the past values of the error term. So basically it is like the current value, the today's value, let's say I'm talking about the today's price, it should be dependent either on the previous prices. So yesterday's price, the last month's price, like that. The previous prices or the previous error terms. When I say error terms, the difference between the predicted value and the actual values of the past. So that is what we are calling as the error term. So basically we are saying these ARIMA kind of models, they assume that the current value, whether it is a price or returns or whatever it is, the current value is dependent on the previous values of the same element or they are also dependent on the previous error term. That is what is the scenario where we are going to use the ARIMA category of model. So here we talk about three stages. One, from my historical data, I should be able to identify an appropriate model. So when I say identification here, I am basically determining the order of the model. So how many past values? So basically I have to find out the number of past values on which my model, the current value is depending, and also the number of past error terms the current value is dependent upon. So this is what is the model identification process. So when I am talking about the number of past values, this is to do with the auto regression term, AR term. And when I am talking of number of past error terms, this is to do with the MA, the moving average part. So I have to identify what is the order of the model. So that is my first step in any ARIMA modeling. And based on that, I have to come out with an estimation, right? Estimation of the parameters. So when I say parameters, okay, I have identified that the past 2 months values. So current month is dependent on the last month, and so the current month T is dependent on the value T minus 1 as well as T minus 2. Then how much weightage should I give to T minus 1? How much, what should be the weightage I should give to T minus 2? These are what I am calling as the parameters. So I have to estimate the parameters of the model. And in general, the parameters of the model are estimated using either a least squares mechanism, either the least squares approach, or we can use the maximum likelihood approach. So different cases we can use different kinds of approaches to estimate the parameters. We know that when we are doing a regression kind of an exercise, we'll use the ordinary least squares mechanism, and when in some cases where we don't have the dependent variable, we can even look at the maximum likelihood based approximate estimation mechanism. So the first step is I am looking at the order, right? And for the order, I can use different kinds of mechanisms again. When I have to determine the order, I can use either a graphical method to find out what is the order of the model, or I can very well use information criteria. We'll see when we are actually implementing it in a practical way. We'll use what is called as information criteria. Two major information criteria: AIC, which is called as Akaike's information criteria. Then we also have BIC, which is called as Bayesian information criteria, or the same thing is called as Quartz information criteria. So one of these criteria is typically being used to identify the best possible kind of a model. And for that particular model, we are going into the estimation of the parameters when we are building an ARIMA model. And the third stage is the diagnostics. So we are actually checking. We are very much checking the model. The model that we have got created in the step 1 and step 2, I have to really check whether it is adequate, whether it is sufficient to do the forecasting. So basically what we really look out here is we look out for the residuals. We see whether the residuals are behaving as a white noise or not, which means the residuals, the error terms that are coming up, they should not have any kind of dependence within the residuals. The residuals are completely independent of each other. So that is what we do as a part of the diagnostic checking exercise. So that's one more thing we have to make sure when we are going ahead in terms of doing a ARIMA based modeling of the time series data. So we'll try to do these 3 steps on a data set. We'll take a data set, we'll try to implement all these 3 stages and try to use the model for the forecasting purposes. And for this, I suggest that we use Forecast, a package called Forecast. You install the package called Forecast. So let's implement, let's start R. Okay. So let's install a package called Forecast. I'm installing. I'm selecting India, and here is where I'm installing a package called Forecast. Okay, I'm installing a package called Forecast. So this package is installed successfully. So let's Let's